History of logarithms. Logarithms were invented independently by John Napier, a Scotsman, and by George Bergy, a Swiss. Napier's logarithms were published in 1614. Bergy's logarithms were published in 1620. The objective of both men was to simplify mathematical calculations. This approach originally arose out of a desire to simplify multiplication and division to the level of addition and subtraction. Of course, in this era of cheap hand calculator, this is not necessary anymore, but it still serves as a useful way to introduce logarithms. Napier's approach was algebraic and Bergy's approach was geometric. The invention of the common system of logarithms is due to the combined effort of Napier and Henry Biggs in 1624. Natural logarithms first arose as more or less accidental variations of Napier's original logarithms. Their real significance was not recognized until later. The earliest natural logarithms occur in 1618. It can't be said too often, a logarithm is nothing more than an exponent. The basic concept of logarithms can be expressed as a shortcut. So, multiplication is a shortcut for addition, exponents are a shortcut for multiplication, and logarithms are a shortcut for exponents. The present definition of the logarithm is the exponent or power to which a stated number, called the base, is raised to yield a specific number. The logarithm of 100 to the base 10 is 2. This is written log with base 10 of 100 equals to 2. Before pocket calculators, only 3 decades ago, the answer was simple. You needed logs to compute most powers and roots with fair accuracy. Even multiplying and dividing most numbers were easier with logs. Every decent algebra books had pages and pages of log tables at the back. The invention of logs in the early 1600s fueled the scientific revolution. Back the scientists, astronomers especially, used to spend huge amounts of time crunching numbers on paper. By cutting the time spent doing arithmetic logarithms, effectively gave them a longer productive life. The side rule, once almost a cartoon trademark of a scientist, was nothing more than a device built for doing various computations quickly using logarithms. You can use logarithms in mortgage calculation. If you have a limit value to pay monthly for your house mortgage, and if you wonder how many months needed to pay, you need to use logarithm. With a fixed rate mortgage, the borrower agrees to pay off the loan P completely at the end of the loan's term, so the amount owed at month end must be zero. For this to happen, the monthly payment C can be obtained from the previous equation to obtain. For example, you plan to get $100,000 from bank and interest rate is 0.15, and you plan to pay each month $100. In this case, you can write this logarithmic function, and by the help of logarithm you can calculate how much money you can pay, how much money you will pay each month. So let's learn what a logarithm is. So Logarithm can be explained like this. So, if we have like A, B, and C numbers, and we write logarithm with base A, B equals C, this means that A over C equals to 5. So A over C equals to B. For example, if we have A like 3 and C as 9, what would B be? So let's put it in the logarithm. Logarithm with base 3, 9. We can write this logarithm as 3 over x equals to 9. So x would be equal to 2. This is basically what a logarithm is. Examples of logarithms. So, logarithm with base 2 of 32 equals to x. So, we can say that 2 over x over 2 equals to 32. How can we solve this question? So if we multiply 2 by x times 2, so 2 times 2 equals to 4, 4 times 2 equals to 8, 8 times 2 would equal to 16, and if we multiply 16 by 2, it equals to 32. So we need 5 2's to get 32. So x would be 5. So right now we have a basic idea of what logarithms are, but there are some simple rules to logarithms. Rules. So if logarithm with base 10 of b is written, this is equal to logarithm b. We can basically write this. Also, let's write 1. Also, logarithm with base a of b can be also written as ln b. Second rule. Logarithm with base a of a is written, it's equal to 1. And if a logarithm with base a of 1, if the number that is taken logarithm is 1, this is equal to 0. Third rule. A logarithm with base a over n of b over n can be written as n over n times logarithm with base a of b. So what this means is basically we can put this n, let's make this one x. If the base has a power, the power of the base is written like, and if the base, not the base, if b has a power, then it's written like n times logarithm a base b. It's the same. Rule number 4. Logarithm with base a b times c can be also written as logarithm base a b plus logarithm with base a of c. These are equal. Rule number 5. Logarithm with base a can be written as logarithm with base a of b minus logarithm with base a b. Rule number 6. Logarithm with base a of b can be also written as logarithm with base c of b divided by logarithm base a of b. Wait, logarithm with base c over a. I'm sorry, this is a. Rule number 7 is logarithm base a of b can be written as 1 over logarithm with b base b of a. Rule number 8. Logarithm with base a of b is equal to logarithm the same goes for b. So like if you write minus logarithm with base a, we should write b 1 over b logarithm. And our last rule would be a number like a with power of logarithm with base b of c can be also written as number c, like the number that has the logarithm can be written with base b of a. So basically these change places. So if we take a look at logarithmic graphs, we already talked about logarithm with base n of n is equal to 1. We gave a for n, but it's the same thing. So this is basically just the natural number, real number. Like we can give 3 for n, and this will be 1 as well. So what this basically means in a graph is that if the logarithmic line passes through n, it meets at n at 1, because 1 is y. So let's solve some example questions. So if we take this, what's x? This is kind of easy to solve. So what we basically do is we rewrite this logarithm like this. This is the first thing we learned. So what numbers has the if we take this of what number, it equals to 4. So we take this to the other side and we write this as x equal to 4 the power of 2. So x is 16. Let's say what is x? So basically we take this logarithmic function to here. So what it enables us to do is to rewrite this like this, because it's 5/1, and this tells us that we can rewrite this, take this to the other side, and say 3x plus 8 equals to 2/5. 2/5 is equal to 32. So 32 minus 8 is equal to 3x. 24 is equal to 3x. So x would be 8. And in this question, it says logarithm with base 10 of 2 is equal to a, and it's asking us what logarithm with base 10 of 5 is. So logarithm with base 10 of 5, how can we write this? We can say logarithm with base 10 this is equal to 5, and we can write this as logarithm with base 10 of 10 minus logarithm with base 10 of 2. It gives us logarithm with base 10 of 2 as a, and this is equal to 1. So basically what logarithm with base 10 of 5 can be written as 1 minus a.